Again, welcome. So it's our morning meeting this week, right? Third Wednesday, getting into it. Not sure where some of the other people are. Hopefully they'll trickle in when they remember that, oh yeah, it's the third Wednesday, so we're alternating. Yeah, as always, add yourself to quick reports. I was hoping to discuss some agenda items, but I don't think the right people are here today to discuss this. I had a slight discussion yesterday with Doug and Lindsay and Tebow about it, but just putting it on the radar. This is part of my quick report anyway. So I have put I put my changes onto the cross gradient, my PR, my suggested changes for cross gradient on there. I did it as a PR onto Xiaolong's branch, like from my own stuff, so we can look at that. So I wanted him to be able to see the changes that I was making instead of just pushing it directly to his branch. I just wanted them to see it first and provide their input as well, like make it a little bit more back and forth and transparent, as far as just like, okay, well, this is the way I think it should be done, so I'm doing it that way. I didn't want that. I wanted them to see like, well, this is what I had in mind. What do you guys? I want them to play around with it. So I was hoping they would be up, and maybe they'll put there. But if you guys also have comments on it, you can look at that as well. I linked to it in the PR, the original cross gradient PR. There's a link to the other PR on Xiaolong's branch. It's not as findable, so that's why I put a PR or a link to it there. But in general, I was thinking about having a discussion on the naming. We can put this off to next week. It's okay. The naming scheme of what we call when there's two models linked together in a joint inversion, what that regularizer is called. My opinion, like obviously joint is too vague because joint encompasses way more things than that, right? My also personal thinking is that the word coupled is also too vague, because I've seen that used for many other types of inversions, many other meanings for that as well. So my personal thought is that I kind of like the word similarity measure because it's explicit in doing what it's like, in saying what it is. Like it's like, oh, I'm going to measure how similar these models are. So I'm going to use a similarity measure to do that. That's just my personal preference on it. But anyway.
You got my vote, Joe.
It's still like, in my opinion, the term seems like, it does seem like encompassing of that, two models linked together. The point is we are measuring how similar they are and I want to enforce them to be similar. So that's the point of those like cross gradient terms, or those linear correspondence mapping, or mutual information, right? They're all measures of similarity between models.
Joe, why do we need that kind of distinction?
Because a lot of, mostly because it's a level of abstraction that we can use for directives. So some of those, like a lot of those directives can be pretty similar to each other. It just makes it a little bit easier to design around, okay, we're expecting this regularization to have two specific models. So it makes the directives a little bit easier to generalize.
So it is limited, that the similarity measure is limited to two physical property then? Is that the idea?
That would be the idea.
Oh, okay.
I'm just measuring how similar one model is to another model. It's, I don't know, it's just kind of, I'm not sure still sure if that's the right word yet, but that's kind of where I'm leaning. Other than that, so the cross gradient PR has a little, like if you see the changes there that I'd suggested to it, it's a little bit different internal implementation that from my experience saw a little bit less of the checkerboarding issues that were kind of apparent in some of the other examples. And other than that, there's the directives. in that branch I feel are probably good to go for the most part. There's a few things that we can iterate on and improve further, but I think at this point it's probably fine to bring them in.
Is it generalized for 1D as well, Joe?
I mean, I've tested them on 2D, like it's tested on 2D and 3D. I mean, cross gradient doesn't really work in 1D because everything is similar in 1D on cross gradient terms. So that's what I've been working on this last week for is SimPEG related stuff. So yeah. Devin, what have you been, I guess, see on there?
Yeah, I got a couple things, just going through the pull request for the EM1D. So got that up to date with master and looking through the examples. So found a couple little details that I fixed. Everything seems to be working pretty well, except for the frequency domain inversion, where we invert for the height of the source. So that one's a little bit interesting. I mean, I understand how the mapping is working and I can get it to run, but something's in there. I don't know if maybe there's a different strategy for trying to do regularization on it. Yeah, something is not working very well in there and we need to figure it out, but mostly it's looking quite good. The other thing is trying to do an initial build of the website for SimPEG using the same kind of structure we have for discretize. So I've got an initial build of that, and the layout of that, the layout style of the website is now like it is for discretize, and just kind of starting to build the API and fill that in slowly. But I've got a couple, I guess, incompatibilities with the graph viz. Yeah, so I even tried to build the discretize website from main branch locally on my computer, and I ran into the same error. So it's not that there's something that I didn't do properly in SimPEG. There's some kind of incompatibility with either the OS I'm using or the or my Python environment. So I need to figure that out. So, you know, making progress, but I've got a couple things that I want to figure out why it's not building and making me happy, or building with errors, let's say. So that's about it.
So I would like to had a question. I noticed on the branch that you were working on for the M1D stuff, you had to put in a thing there like to where it had to be able to calculate its fields.
Yeah.
Why was that? Like, because you said it broke a directive, but which?
Yeah, let's see. One of it was maybe, how did this work? It might have broken in the directive that chooses the initial beta based on the eigenvalue. I'm not sure exactly where it was breaking, but it basically said you need fields. It doesn't have fields. And so, similar to some of the other simulation classes that has kind of a simple fields objects, or when dpred just calls fields, I did the same thing.
Yeah. So it's still like, it feels like a hack to me to do it that way, because it's like it's when you would call a fields object, most of the time I'm expecting some sort of like thing that's related to field. When you call it like that, right, it just returns your data. It seems very odd to me, like, to have to do it like that. So I'd be curious to look into like actually changing the thing that's causing an issue, rather than supporting like calling fields from a 1D simulation when we don't have fields everywhere.
Yeah. I mean, that's fine by me. I don't know if you want to like create an alias for it and just say that they're the same, but yeah.
I'd rather just like not have the fields on those objects personally. Because what are the things, so when to do a SimPEG inversion, right, we just need to, I mean, I didn't think fields were a necessary part most of the time. Does it just return none? Like if it just had none as fields, would it work every time?
Oh, that's a good question. So I can maybe play around with it a little bit more and kind of maybe document what the error actually is.
There might be some places where, like, I think we passed the fields around in the data misfit, because for some examples, like if we've computed the fields for 3D time dominium, like we don't want to recompute them. We should allow none, but I wouldn't be surprised if there's places where we assume that something's passed in there. But if you pass, we should be able to pass around to none, I think.
All right, so I think that'd probably be the better solution, is just to have it return none if you call fields, just because that's pretty clear, right? Like if that works, like I'd rather do it that way.
Yeah, I'll test that out today. I mean,
Cool. Anything else, Devin?
no, not really. Those are the two things I'm working on these days.
Okay, say, Lindsay.
Yeah, quick update. The line current pull request is basically ready to go. So we've got it now for time domain, frequency domain. Well, the EB formulation was already there, but now the HJ formulation is there. So you're welcome to take a look. Feel free to add any comments. Still missing tests. If somebody has a test or an example that you would like to just turn into a test, that'd be great. If not, that's fine. I'll try and get back to that, but it'll probably be a couple weeks. So yes.
Even like as a test, it's just anything small, anything to just double check it's doing what you think it should be doing. Like it doesn't have to be a super involved convergence test of line current source to an analytic thing. Like,
yeah, I don't think it needs to be too like an analytic or anything, but I think what would be nice is to test that like the EB and the HJ are giving something comparable for like a wire. Would be a nice test. But that will take a little bit to set up. I could definitely set up the very simple test that checks that, you know, ones are where they're supposed to be. But yeah, a quick dipole test or like line current test would be quite nice between the two.
Yeah, I mean, I already have, I think I already have like a code validation thing set up for this already. I could try and run it through that on the branch that you're working on.
Sure, if you want to take a crack at it, that'd be great. It's on the TDEM-cleanup branch.
TDEM-cleanup?
Yeah.
Okay.
Lindsay, did you extend that for like the phase integrals? Is that what you've done? Oh, nice.
Yeah. Yep, and I put some checks in there just because of things I've run into in the past to make sure that it's like the divergence is only where it should be. So to make sure you haven't like accidentally missed a face or have a disconnected wire or anything. So there's a few sort of sanity checks built in there. So feel free to take a look. I'd be curious to hear any thoughts.
Yeah,
I remember.
Oh, go ahead, Kevin.
Well, I remember with that original implementation that we had of it that I was using for some of the stuff in my thesis. It worked best if you were in an octree mesh, if it was if your source was only running through like your core cells and if there weren't like changes in the cell size. I remember seeing some things with that. So I don't know, I guess that's just another thing to think about because I don't know if anybody has looked at that or addressed that yet.
That's a good point. I don't check for that, but at this point, I also think that's maybe a user thing. We can try and put some guardrails in place, but yeah, at least actually right now it's checking the divergence. And so if you did something funky with an octree mesh, it might catch that, but I'm not too sure.
yeah, right now with the octree mesh for the other formulations, right, it finds right the path, the cells through the path and makes sure they're all at the same level. And we're like, okay, well, if it crosses level changes, then it's weird, and it gives a warning back, at least letting you know you did that. You probably shouldn't.
I actually have a curve node started where I was playing around with the line current before. So I have like an example kind of set up and just playing with. And I'm then doing the code coverage for the simulation MT. So I'm writing tests. So I can probably pull that in, or at least tackle or try that out for sure.
That'd be awesome, John. So maybe you and Devin can coordinate. If you both have examples, maybe it's just a matter of stitching them together. That'd be awesome.
Okay, cool. John, speaking of,
Yeah, I'm almost there, 74%. Just gotta get up to 78, and then that PR will be good to go. So I'm progress finally. I'm getting there. Slowly
Good.
but surely.
like I said, like it does help. Like writing the test is useful because you find bugs that you didn't know you put in.
Exactly. Yeah. Already found a few, so that's it works out really well. And then now I don't know, it makes for better understanding of the code. Actually, it was kind of nice to go through and see that all the stuff that you did in the base there. Might have still some questions. I keep telling them I'm going to bug you, but I don't. But I'll get there one day.
Okay. Any other reports? Soggy, Mike, what have you guys been up to? TiVo?
Yeah, I made much commit on SimPEG for the past week. Yeah, like so I moved all those PGI improvement to that regularization refactor PR. So it's waiting for the PR 1038 from DOM. It should be ready. This one should be ready to go, but I believe it didn't update it from. It didn't pull the latest main in it. I think that was the only thing in that PR from DOM going in. So yeah, that's I'm just waiting for that in terms of that specific PR, and
Yeah.
we'll wait to hear from DOM.
Yeah, I think that's one of the branches that I can't modify. I think he did that PR and didn't select like allow moderators to edit. I have to double
Could be
check.
haven't tried myself. Like I think the repo is public, but yeah, maybe they have like writing access limitations. That would make sense.
Yeah, because I can't like merge main into it.
Nothing really particular on my end. Couple like not that necessarily related to SimPEG. A couple interesting things that I learned recently. All the AGU journals, it's actually force you to upload the data. So that's the requirement actually now, which is quite interesting. So yeah, I was actually putting together a data repository through Stanford Digital Library. I think I could have used the other, but yeah, Rosemary prefers whatever Stanford affiliation stuff. But that seems quite interesting. There is like a kind of movement in the journals actually kind of forcing you to. So you cannot really say, oh, data is upon request, which is that's basically means, oh, data is not available. So I thought that's interesting. And the other thing, we're sort of starting a project with the groundwater modelers. And one kind of interesting avenue is how do we really integrate the geophysics into the groundwater modeling calibration, basically in the groundwater inversion. And the way that they want to do is basically putting whatever geophysical software into PEST. So PEST, I'm not sure you guys are familiar with it. It's just an optimization package, but it's quite general. So you can put whatever program if you follow the format. So I thought it's actually a relatively simple task that, okay, we just need a wrapper of SimPEG and then plugging into PEST, and they can use whatever way they want. So yeah, I think given sort of the size of the community is relatively big using that types of softwares. Like there's a couple others. I thought this seems a good opportunity to actually think about kind of plugging in SimPEG to other software, which is sort of where we're moving, I guess. Anyway, so that's that's where I am. I'm not really working, I'm just thinking about the potential and not actually working. But probably at one point gonna work on that. Anyway, that's where I'm.
Exciting. Okay, well, if there's nothing else, I think it's a good meeting time. I don't think we have anything big coming up. Next week is afternoon meeting, it's fourth Wednesday, so 3 o'clock next week. See y'all there.
But
I got a question for Doug if he's still there, and maybe Lindsay if you want to hang on for a couple minutes.